Dr. DeMont here, and welcome to Exploiting a Windows Server Using Shellcode. In this module, we're going to cover shellcode, and we'll do a demonstration about what it is and how to investigate it a little bit. We're also going to do a demo on a traditional Windows Server exploit. That's going to be the main piece of the learning in this module. When we talk about shellcode, really what that means, it's an arbitrary payload that as a attacker we can deliver to a process and it'll run our code. And the reason it's called a shellcode is because traditionally what you wanted was a shell. You wanted to exploit a Unix server, for example, and get back a Unix command prompt so that you had interactive shell access. So in many traditional stack-like buffer overflows, there was kind of a traditional blob where you had NOPs, and that could be hex 90s or capital A's, 41s, or whatever you want, shellcode, and that could be something like connect back to you or exec or execute a particular process or program. And then there's the part where you actually have to overwrite the return address, and that was either something you could hard code or many times now often it's dynamically calculated. How the malicious input, the payload, the shellcode, all of that, it's changed a lot over the years. How it's delivered, how it's used, how it's executed. The process of exploit development continues to evolve and change because when you think about it, we're doing something that you should not be able to do. Programs weren't written to be exploited. Operating systems and chipsets, they were not designed to be exploited in this way. So as a malicious attacker, the art and science of doing this is always changing. So keep in mind as we do this module, these types of attacks are the things that would have worked 10, 20 years ago and might still work today on embedded systems and all types of other applications. But in the coming modules, we'll work toward more and more modern versions of this. Well, how do attackers come up with this malicious payload, this shellcode? You could hand write it and assemble it just like any other program, or more likely, the shellcode is something that's already been written by somebody else, and we can use a framework such as Metasploit to generate the shellcode. Here's an example of using a Metasploit program, MSF Payload. It's been around a long time, and it's changed throughout the years a little bit. In this case, we want to create a Linux reverse connectback shell. So when the attack works and the payload runs, this shellcode will actually connect back to this IP address, 192.168.1.1, on port 444, and this is the binary blob that'll do that. So we need to somehow embed this into our program, and that's the type of thing we're going to be learning in this module. Here's that same shellcode we were just looking at, but now it's been loaded into IDA Pro so that we can take a closer look and see how a Unix or a Linux type shellcode would work. And what we'll see is that it's actually pretty straightforward. It's fairly easy to understand. Every time you see an int 80, for example, that's a software interrupt where the code is asking the operating system for help, and we're just loading a particular syscall in EAX and setting up any other registers and data that needs to be. So this first one sets up a socket of some type, then we do a dupe, then we do another socket, and then we do an execve, and we can see the string /bin/sh. It's a little hard to read. It's in there kind of backwards around the sort of 32 to 37 marks in this shellcode. So we're not going to go through this in painstaking detail and really understand every finer point of this. You can go back to the reverse engineering module to figure out more about reading assembly and all of that. But I wanted to kind of demystify shellcode a little bit because a lot of people feel like, boy, the attacker payload, that shellcode, it's really just, it's magic. And it kind of is in a way, the way that it all fits together. We're, again, doing the art of something that really shouldn't be able to be done. But it's really not magic. It's just some assembly code that's going to execute when we can hijack the control flow pointer to point to our code. Now here's another type of shellcode. This is a Windows shellcode that's going to exec. It's going to launch calculator. Why calculator? Well, that's just something that we do typically in exploit development. It's a way to sort of prove to developers maybe or whoever that this particular vulnerability really is exploitable and we can execute an arbitrary payload. And normally it wouldn't be calc, it would be maybe ransomware or something else by bad guys. But we really don't want to ransom our own files just to test an exploit, right? We just want to, as kind of a test engineer, we just want to write some exploit that does something, and that something typically tends to be just like popping up a calc, and that's what we're going to do for the coming lab. Again, we've loaded the shellcode in IDA, and we're not going to, again, go through it painstakingly slow, but I want to at least point out the major pieces of a Windows shellcode because it's a little bit different than a Unix shellcode. The first thing we do at the top is we call. So we go to another part of this. There's actually 2 pages of this shellcode. I couldn't show it all on one slide. And then when we come back from that call, we'll see a return or a jump. And we come to this main section, which actually decodes function hashes and calls them. And I'll show those hashes to you right now. So here's the other piece of code that we couldn't see on the prior page, but we come to this point where we locate kernel 32 using the process environment block, and that's always at a particular offset 30 hex from the FS register. We see that a lot in traditional Windows shellcodes. And then what's unique about Windows shellcode is that and this, that we set up hashes to functions that will resolve and call them. So we're basically calling Windows APIs in our shellcode rather than doing direct syscalls like we did in the Unix shellcode.